Assalamualaikum and hello everyone. In this video, I'm going to explain on examples in our tutorial notes. Reflection as spherical surface. So before I explain the examples, I would like to re-explain the sign convention for spherical mirror. Okay, as we learn in this chapter, we learn two types of mirror, which are concave mirror and convex mirror. So we have two types, concave and convex. So this is concave mirror and this is convex mirror. Okay, now we learned before review method. Do you remember? Review. So real image, inverted image, virtual image and upright image. So we know we have a mirror and we know this is in front of mirror, in front of mirror, and this is back of mirror, back or behind of mirror. Okay, now if our image formed in front of mirror, it is inverted and real image. But if our image from behind or back of mirror, it is virtual and upright image. Okay, but if we put our object in front of the mirror, it is positive value. But if we put our object behind the mirror, it is negative value. It's a negative sign. So same goes to the image in front of mirror. If it's from in front of the mirror, it is positive, but if it's from behind the mirror, it is negative. What about the magnification? So as you can see from this table, magnification and the height of image. If we form upright image, which means behind the mirror, so our magnification and height of image is positive. So behind mirror, our magnification is positive and height of image is positive as well. Whereas the magnification and height of image is negative when it is inverted, which means the image from in front of the mirror. So negative. Okay, next, radius of curvature and focal length. So as we know, we have center of curvature and also focal length. So this is for concave mirror. So we know concave mirror, the center of curvature and the focal length, the focal point is in front of the mirror. So if it's in front, the radius is positive value and the focal length is positive value as well. So this is for concave mirror. Sign convention for concave mirror. Okay, now let's see sign convention for convex mirror. The same thing, review method. So real image, inverted image from in front of mirror, virtual image, upright image from behind or back of the mirror. Okay, so we know if the object is in front of the mirror, it will have positive sign, and if the image is in front of the mirror, it will have positive sign as well. So if it's behind or back of mirror, the object and the image is negative sign. What about the magnification? As we know, if we got upright image which is behind the mirror, the magnification and height of the image is positive. Same goes to convex mirror. Okay, whereas if your image is inverted, it means your magnification and your height of image is negative, as inverted image formed in front of the mirror. And this is convex mirror. So convex mirror is center of curvature and the focal length is behind the mirror, back of the mirror. So therefore, the radius is negative and the focal length, the focal length is negative as well. So this is how you remember the sign convention for spherical mirror. It's better for you to draw so that you can see it better. Okay, now let's look at example 6.1.1. An object 2 cm high. Okay, so the height of the object is 2 centimeter. It's placed 30 centimeter from a concave mirror. Okay, now you have a concave mirror and the object is placed 30 centimeter from the concave mirror. So your U is 30 centimeter. With a radius of curvature of 10 cm. So the radius of curvature is 10 cm. So for example, the radius of the curvature is here. Okay, radius of curvature 10 cm. Find the location. Actually, the question asks for find the image location and its characteristic. So when we need to find for the image location, it means we need to find for the image distance and also the characteristic of the image. So we will use loss method, which is location of image, object, orientation of image, size of image, and type of image. First of all, we need to look for the image distance. Okay, how can we find for the image distance? So we know the formula for the spherical mirror equation is 1 over focal length equals to 1 over object distance plus 1 over image distance. But the question is, can we look for our focal length? Because we already know our object distance. Yes, we can look for our focal length because we know radius equals to 10 cm. And we know the radius of curvature is 2 times focal length. So therefore, focal length is radius over 2. So our radius is 10 and our 10 divided by 2. So the focal length is 5 centimeter. So what you can do is we substitute our focal length with 5 centimeter and we substitute our object distance with 30 centimeter and we can find for our image distance. So when we press calculator, we will get our image distance 6 centimeter. Okay, now we need to look for the characteristic. So where's the location of the image? So the location of the image actually in front of the mirror. Why is the location in front of the mirror? Because we got our image distance in positive value. So when it is positive value, it means the image is in front of the mirror. What about the orientation? So for the orientation, we know the image is now in front of the mirror. We will use the review method. So when it is review, it means it is inverted. So inverted. What about the size of image? Okay, we will look for the size of image, but we need to know first the type of image. The type of image is real, as the image is formed in front of the mirror. What about the size? We can look for the size by using magnification formula. So magnification equals to height of image divided by height of object, or image distance divided by object distance. We know our image distance and object distance. So now we can look for the magnification. No, not for the magnification. We know our height of image. We know our height of object. Now we can look for our height of image. So we can look for this one. Okay, now, so our height of object is 2 cm and our image distance is 6 cm and our object distance is 30 cm. So when we arrange this equation and press calculator, we will get our height image of 0.2 centimeter. So we know our height of object is 2 cm, while our height of image is 0.2. It means the image is diminished. So the size is diminished. So this is how you tackle this kind of question. Okay, let's look at the next example. Example 6.1.2. A woman who is 1.5 meter. Okay, we have the woman. So the woman is now the object. So height of the woman object is 1.5 meter. It's located 3 meter from an anti-shoplifting mirror. So when we are talking about anti-shoplifting mirror, do you think it's a concave or convex mirror? So it is about safety mirror. So what is it? It it is convex mirror. So we have convex mirror. So a woman who is 1.5 meter is located 3 meter from an anti-shoplifting mirror. So here is your object, 1.5 meter height, and is located 3 meter from anti-shoplifting mirror. The focal length of the mirror is 0.25 meter. Okay, now this is convex mirror. So when we are talking about convex mirror, the focal length is behind the mirror. So this is center of curvature and this is the focal point, and the focal length is 0.25 meter. Find the position of her image. So we need to look for position. We need to look for the image distance. Okay, how can we find for the image distance? We can use the spherical mirror equation. 1 over f equals to 1 over u plus 1 over v. Okay, now I want to ask you, the focal length is negative or positive? The focal length is negative. Why it is negative? Because it is behind the mirror. So 1 over, you substitute the focal length with negative 0.25, and the object distance is 3 meter. The object distance is positive because it is in front of the mirror, and 1 over v. Rearrange the equation and press the calculator. You will get your v negative 0.231 meter. So it means you got negative value for your image distance. It means your image lies behind the mirror. So image is behind mirror. Okay. Okay, now we settle with question A. Now let's look at question B, the magnification. For the magnification, we know we have two formula, which is height image divided by height object, or negative image distance divided by object distance. So we know our image distance and object distance. So just substitute. So you will get your magnification is 0.077. Now we need to look for the height of the image. How do we look for the height of the image? We can use this formula. Magnification equals to height of image divided by height of object. So our height of image, we are going to look for it, and we know our height of object is 1.5. And what about our magnification? Our magnification is 0.077. So your height of image is 0.12 meter. Okay? Alright, now let's proceed to, we are done with number 3, let's proceed to example 6.1.3. Okay, a dentist used a small mirror attached to a thin rod to examine one of your teeth. When the tooth is 1.2 centimeter in front of the mirror, the image it formed is 9.25 centimeter behind the mirror. Okay, first of all, you need to know what mirror is this. So we are talking about dentist mirror. So small mirror that we use at the dentist. It is concave mirror. So our tooth is the object. So our tooth is 1.2 centimeter in front of the mirror. So the object distance is 1.2 centimeter. And the image is formed is 9.2 cm behind the mirror. So it formed behind the mirror. So when it's behind the mirror, it is virtual and upright image. So for example, you will have somewhere here your image, and it is 9.25 centimeter. When your image formed behind the mirror means it is virtual and upright image. Okay, find the focal length of the mirror. So your V is behind, your image distance is behind the mirror. So your image distance is negative 9.25 centimeter. Okay, find the focal length. So we can use the spherical mirror equation. 1 over f equals to 1 over u plus 1 over v. So this is v, my v look like u. Okay, so 1 over f equals to 1 over u, 1.2 plus 1 over negative 9.25. So when you rearrange the equation and you press the calculator, you will get an answer of 1.38 centimeter. Okay, can? Okay, now we are going to look for the magnification of the image. So for the magnification of image, we can use this formula. Whether height of image over height of object or image distance over object distance. So we know the image and object distance, so we will use this formula. So our image distance is negative 9.25 and our object distance is 1.2. You press the calculator, you will get an answer of 7.71. So this is your magnification. And please remember, magnification does not have any unit. Okay, now let's look at example 6.14. A shaving or makeup mirror from an image of a light bulb on a wall of a bathroom that is 3.5 meter from the mirror. Okay, when we are talking about shaving or makeup mirror, immediately we know it is concave mirror. A shaving or makeup mirror from an image of a light bulb on a wall of bathroom that is 3.5 meter from the mirror. So the image from is 3.5 from the mirror. So your V is 3.5. And if it's formed in front of the mirror, it means the image is real and inverted. So because we know the review method. Okay, so now we will have the image somewhere here, alright? So we will have the image somewhere here because it's inverted. Okay, the height of the bulb is 8 millimeter. Alright, let's see. The height of the bulb. So height of the object is 8 millimeter. So it is 8 times 10 to the power of negative 3 meter. And the height of the image is 40 centimeter. So it means 40 times 10 to the power of negative 2 meter. So as you can see here, it means the image is larger than the object. So it means there is magnification. So it is magnified because height of image is larger than height of object. Therefore, you will get your image large but inverted and real. Okay, now let's look at the question. Okay, the first question actually it asks for sketch a label ray diagram to show the formation of the bulb image. So we need to sketch ray diagram. Okay, we know this is concave mirror and the first question, sorry, I didn't copy the question. Okay, sketch a label ray diagram. So you can look this at your note. Okay, sketch a label ray diagram. So we know we will get a magnified image but real and inverted. So it means your object is between focal point and center of curvature. Okay, how do we tackle this kind of question? Okay, now we will have concave mirror. So now we will have center of curvature and focal point. In order for us to get magnified, real and inverted image, your object must be in between center of curvature and focal point. Okay, now I will draw the ray diagram. So I'll use different color. Okay, now ray travel parallel to principal axis and pass through focal point F. And another one, ray travel through focal point and reflected parallel along principal axis. So here, where is your object will form? So this is how you sketch a label ray diagram. But then you need to label your focal point, your center of curvature, your pole vertex, and you need to label your distance as well. So we know the image distance from the mirror is 3.5 meter. And your height of object is 8 millimeter, height of object, and your height of image is 40 centimeter. So this is how you sketch a label ray diagram. And next, we need to calculate the position of the bulb of the mirror. So we need to calculate position of the bulb from the pole of the mirror. So this is the pole of mirror. So we need to calculate our object distance. So we need to look for our object distance. Okay, how can we tackle this question? Can we use the spherical mirror equation, this one? 1 over f equals to 1 over u plus 1 over v. No, we cannot use this equation because we don't know our focal length. But we can use this formula. Magnification equals to height of image, height of object equals to negative image distance over object distance, because we know our height of image and our height of object. Okay, our height of image is 40 times 10 to the power of negative 2 meter. And our height of object is 8 times 10 to the power of negative 3. And our image distance is 3.5 meter, and we are looking for our object distance. Therefore, our object distance is, when you press the calculator, you will get 0.07 meter. Okay, we are done looking for the position of the bulb from the pole of the mirror. Now we are going to look for the focal length. Okay, now for the focal length, you can use the spherical mirror equation, which is 1 over f equals to 1 over u plus 1 over v. So 1 over f, and we already know our object distance is 0.07, and we already know our image distance is 3.5. And of course, rearrange the equation, we will get, and press the calculator, we will get the focal length of 0.0687 meter. Can? Okay, now next, example 6.15. What is the focal length of convex spherical mirror which produce an image 1/6 the size of an object located 12 cm from the mirror? Okay, first of all, I love it when you draw it first because you can see it better. So we have convex mirror. So the question asks us to look for the focal length. Okay, and we have an object located 12 cm from the mirror. Okay, the object distance here is 12 centimeters. So this is my object. And then the question says the magnification is 1/6 of the size of an object. So 1 over 6. So how can we look for the focal length? So we can use this formula. Magnification equals to height of image divided by height of object equals to image distance divided by object distance. But we don't know our height of image and our height of object, but we do know our magnification and also our object distance. So let's look for our object distance. So negative v over u, and our u is 12, so we will get our image distance of negative 2 cm. So when we get negative 2 cm, we got negative for our image distance, means our object is behind the mirror. And if it's behind the mirror, it is virtual and upright image. It is virtual and upright image. So you get your image here. So you get your image here. Okay, can. Now we need to look for the focal length. So we can use the spherical mirror equation. So 1 over f equals to 1 over u plus 1 over v. So your object distance is 12 cm, your image distance is 2 cm. So when you press the calculator, you will get negative 2.4 cm. This is, so the focal length is here. The focal point is here, so the focal length is negative 2.4 cm. Can? Okay. Next question. So next question is example 6.1.6. When an object is placed 20 cm from a concave mirror. So we are having concave mirror. So this is concave mirror and this is convex mirror, okay? Concave mirror. Object is placed 20 centimeter, so the object distance is 20 centimeter. A real image. So we know the review method. Review method. So if it's review method means we have real image. So if real image here, it means the image is from in front of the mirror. So in front of the mirror, it is inverted. So it formed 3 times. So the magnification is 3 times. But because it formed in front of the mirror, the magnification is negative. So negative 3. And we know we need to look for the focal length. We can use this formula, magnification. If you're looking for the focal length, we need to use the spherical mirror equation. 1 over f equals to 1 over u plus 1 over v. We do have our object distance, but we don't have our image distance. But we can look for our image distance by using this formula. Negative image distance over object distance. And our magnification is negative 3. And we are looking for the image distance, and our object distance is 20 centimeters. So we will get our image distance 60 centimeter. So now we can put into this equation and we can find the focal length. So 1 over u is 1 over 20 plus 1 over 60. So you will get your focal length. How much you will get your focal length? You will get your focal length 15 centimeter. Where the object must be placed? Okay, I think there's something wrong with this question because it already given the object must be placed 20 centimeter from a concave mirror. So this question is not valid. Okay, now last question. Upright image. Okay, first of all, I would like you to highlight upright image is from 20.5 centimeter from the real object. Okay, when you say upright image, remember, for example, this is your mirror and this is in front of mirror and this is back of mirror. So we know we use the technique review. Review. So upright always from behind the mirror, back of the mirror. Okay, so now you have a real object. So real object. So the object is here and the image is from here. So from the object to the image, the distance is 20.5 centimeter. So it means object distance plus image distance is 20.5 centimeter. Alright, the image height, so height of the image is 1/4 of the object height. So 1 over 4 of the object height. Okay, now where should the mirror be placed relative to the object? Should the mirror be placed here or here or here? So we need to determine the distance of object. For the first question, we need to determine the distance of object. So how do we tackle this question? So let's list out all the information that you have. So you know, object distance plus image distance is 20.5 centimeter. And the height image is 1 over 4 of the height object. Okay, so we have 2 information. So what we can do, we need to find for the u, right? For the object distance. So what we can do, we can use the magnification formula. Height image over height object equals to negative image distance over object distance. Okay, so we know height image is 1 over 4 of height object. So we substitute height image with 1 over 4 height object. So divided by height object equals to negative. And wait, look, we know because it's upright, the image from back of the mirror. So when it's back of the mirror, the image distance is in negative. So we need to substitute the negative first, negative v and over u. Okay, so we can cancel the height of the object. So we left us with 1 over 4 equals to v over u, and v equals to 0.25 u. As we know, 1 over 4 is 0.25. Okay, so this is our first equation, and our second equation is u plus v equals to 20.5 centimeter. So this is our second equation. So equation 1 into equation 2. So u plus, so we substitute v with 0.25u equals to 20.5. So when you rearrange the equation and press the calculator, you will get u equals to 16.4 centimeter. So the mirror should be placed 16.4 centimeter in front of the object. So we need to make sure the mirror is put 16.4 centimeter in front of the object. Okay, let's look at the second question. Calculate the radius of the curvature of the mirror and describe type of mirror required. So we need to, when it say describe the type of mirror required, so we need to determine whether the mirror is concave or convex. Okay, let's settle B. Radius of curvature. How do you look for it? And what is the formula for radius curvature? Radius of curvature equals to 2 times of the focal length. So we already know our u. Our u is 16.4 centimeter. And we just need to look for our v. Then we can find for our focal length. After we find for our focal length, we can put into this equation. So how can we determine v? We can determine v from equation 1. So we can determine v from equation 1. So equation 1, v equals to 0.25u. So 0.25, our object distance is 16.4. So this will give us, okay, we'll calculate later. But remember, because the image form is behind the mirror, so it will have negative. Okay, so we can use the spherical mirror equation. 1 over f equals to 1 over u plus 1 over v. So 1 over f equals to 1 over u is 16.4 plus 1 over, just substitute the v here, negative 0.25, 16.4, 16.5. And then we will get focal length negative 5.47 centimeter. And we know the formula is radius equals to 2f. So radius equals to 2 times by f. So radius equals to 2 times by negative 5.74. So will give us negative 10.9 centimeter. Okay, so how can we determine the type of the spherical mirror? So what do you think? So we got our focal length in negative. Remember when I say when our focal length is negative, it is convex mirror because it's behind the mirror, back of the mirror. So the radius also negative, right? So it is what type of mirror? Convex mirror, because our focal length is negative value. Okay, so it's convex mirror. Okay, C. Sketch and label a ray diagram to show the formation of the image. Okay, very good. First of all, I'll let you to determine the characteristic of the image, so it's easier for you to draw it. So the location of image behind the mirror. So we'll use the loss technique. Orientation, up, right. Size of the image is diminished. Do you think it's diminished or magnified? It is diminished. You know why? Because the image height is 1/4 of the object height. So it is diminished. So size diminished. Okay, the type of the image that form is, what is it? Virtual or real? It is virtual because it is back of the mirror, because the image form back of the mirror or behind the mirror. Okay, now we already got the information. What mirror we will use? We will use convex mirror. Okay, and the object is of course real object. The object is here. So we know if convex mirror, the focal point and the curvature is behind the mirror. Okay, now let's start. So of course my favorite is the ray travel parallel to the principal axis and pass through focal point. When it passes through focal point, it will reflect it back. And then another one is pass through the center of curvature. So, and reflected back through the center of curvature. And, okay, now, so where's the image form? The image form is here. Please make sure to remember wherever you draw behind the mirror or back of the mirror must be dotted lines. So this is your pole vertex. Okay, so this is front and this is back. So this is your ray diagram. So you can see the characteristic is the same as the ray diagram that we draw. Behind the mirror, upright, diminished, and virtual, because it's behind the mirror. Okay, that's all from me for the examples in your tutorial notes. So you can try to answer all the exercise question in the tutorials notes, page 76, 77, and 78. Alright, bye-bye.